Hello everyone. In my today's class, I would like to discuss conic sections part 2 in continuation to my previous session, conic sections part 1. Conic sections part 1. In our last class, we have discussed different methods to create ellipse, like tangent method. Then we have seen oblong method, rectangle method, concentric circles method in our last class. But in today's class, we will see how to create ellipse, parabola in different methods. In this session, we will see the how to create uh, parabola in different methods. So let me move further to see. Uh, First method is rectangle method. How to create a parabola in rectangle method? We will see. We will take one example now. A ball thrown in air. Uh, Attains 100 meters height and covers a horizontal distance of 150 meters on ground. So draw the path of the ball or the projectile. In turn, we can also call this method as a tangent method. We will see why we are going to call this method as tangent method. I'll tell you after constructing the parabola in this method. I repeat this problem once again. A ball thrown in air attains 100 meters height and covers a horizontal distance of 150 meters on the ground. That means the range is 150 meters. The altitude is 100 meters. Then we have to draw the path of the projectile. So there is a specific method. That method is called rectangle method or tangent method. Now draw a rectangle of height 100 meters and length 150 meters. So with the given dimensions, draw a rectangle, the length 150 meters, and height 100 meters with the given dimensions. Then divide the height, into convenient equal divisions. Say in this case it is 6. Okay, so and similarly divide the half of this rectangle along length, half of the length into the equal number of divisions that we have done in the height. So same number of divisions, so total 6 divisions. So this we have done 6 divisions, and similarly this also needs to be divided into 6 equal divisions. Suppose if we divide this height into 8 equal divisions, then we have to divide the half the length of this rectangle is also into 8 equal divisions. So name all those points: 1, 2, 3, 4, 5 and 6. So we are divided the height of the rectangle into 6 equal divisions. In this case need not be 6. If we want to increase the accuracy of the curve, or if we want to get the smooth curve, we need to increase the number of points here. So when we go on increase more number of points, the curve that we get is more smooth. More points we will get. We can draw curve very easily. Then name all these points also. Then this is also 1, 2, 3, 4, 5 and 6. Then then you join the vertical line at the midline of this rectangle with the vertical divisions. Join all these points like this: 1, 2, 3, 4, 5 and 6. So, and similarly project these points into the other side of this rectangular height. So 5, 5, simply we can project these points onto the opposite side of the rectangle like this. After marking all those points, similarly join those points. These points are also uh, like we have done in the left side of the rectangle. Join all those, then divide the same number of divisions on the right side of the rectangle on the length of the rectangle. So similarly like this, join all those points like this. After joining the mid of the rectangle with the division points on the height of the rectangle, then draw the vertical lines from the horizontal points. So that we are already divided here. Okay. Then we have 1, 2, 3, 4, 5, 6. So horizontal divisions, we have divided the half of the rectangle into same number of divisions that we have done in the case of height of the rectangle. Okay. So then draw the vertical lines from these points. Project these points, one point to one point. So which will intersect one point. So we will get one point. Then second point and second point. So second point and drop that vertical line up to the second line. Draw the vertical line from the point 3 up to the third point. Draw the vertical line up to the 4, then 5 and 6 we will get at this location only. Then, so repeat all these vertical lines for the right side of the rectangle also. So we are obtained the different points here. So one is our starting point. Then this is our starting point, of course, origin. Then this is our second point. Third point, 2 and 2 is intersecting at this location. Then third line and third line is intersecting at this location. 4, 5 and 6. And by joining all this, and similarly to the right side of the rectangle also, 5, 5 is intersecting at this location. Then 4, 4, 3, 3, 2, 2, 1, 1. Then join all those points to get a smooth curve of a projectile of the ball. So joining all these points will get a smooth curve, so which is also known as parabola in rectangle method or tangent method. I repeat this once again. So draw a rectangle with the given dimensions. In this case, the length of the rectangle is 150 meters. So that is the range. Then the height is 100 meters. So length is 150 meters. Height is 100 meters. So by taking scale, 1 meter is equal to 1 millimeters. If we take the scale, this length will become 150 millimeters and height will become 100 millimeters. So we should specify scale here. 1 meter is equal to 1 millimeters. So that construct a rectangle of length 150 meters, height 100 millimeters. So then divide the height of the rectangle into the convenient equal number of divisions like this. In this case, I am dividing into 6 equal divisions like this. And similarly, the half of the length of this rectangle, the half length of this rectangle is also divided into the equal number of divisions that we did in the case of height. So in this case, we have done 6 divisions, and similarly here also we have to do 6 divisions like this: 1, 2, 3, 4, 5 and 6. Okay, so then mark all those points: 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, and similarly mark these points also and join these points. Join these points to the top point of the topmost midpoint of the bisector of the rectangle. So the top point of the bisector of the rectangle, join all these points like this. After naming all these 1, 2, 3, 4, 5, 6, join 1, 2, 3, 4, 5 and 6 like this. And similarly, so projecting all these points into the other side of the rectangle, the other half of the rectangle. So, and name all those points as 1, 2, 3, 4, 5, 6. Similarly like this. Then divide the horizontal line of the other side of the rectangle into 6 equal divisions like this. Then join all these vertical divisions into the vertical bisector of the rectangle at the top like this, 2, 3, 4, 5 and 6. Then project these horizontal line divisions vertically upwards, and this point 1, this division is going to intersect the first inclined line at this location, then second, third, up to third line, fourth up to fourth line, fifth up to fifth line. Then repeat this step in the other side of the rectangle. Now we are obtained the different points to get a different curve. Let us see what we will get in the next animation. So we are obtained the starting point here. So it is 0 0 and 1 1 we got here, 2 2, 3 3, 4 5 6, then 5 4 3 2 and 1. Similarly we have 0 here. So if we join all these points, we will get a smooth curve. That curve is a parabola in rectangle method or tangent method. So let me join all these points like this to get a smooth curve that is known as parabola in rectangle method. Parabola in rectangle method. Now let us see the other method, that is the parabola in tangent method. But in this case, so this method is only known as the rectangle method, but whereas this method, I will explain you the tangent method in this problem. So draw an isosceles triangle of 100 mm long, base 110 mm long, altitude, inscribe a parabola in it by the method of tangents. Please make a correction that this method we are not going to call as tangent method, but here we are not used any tangents. So please make a correction. So this method is called only rectangle method. We cannot call this method as tangent method. Please note this point. We cannot call this as tangent method. We are going to call this method as only rectangle method, because we are not drawing, we are not obtained the curve from the tangents. So in this case, specifically, we are obtained the points. We are obtained the points, and from those points, so we have drawn the curve. That curve is a parabola here. So this curve, this parabola, we are not going to call as tangent method. We will call this as rectangle method only. Please make this correction. So then let me move further to see the parabola in tangent method. It also looks similar, but there is slight difference between rectangle method and tangent method. In the previous case, so we got specific point, but whereas in this case, so we are not going to get the point, but we have to draw a curve by touching to the different lines, so as a tangent. So that's why we are calling this method as tangent method. I read out the problem once again. Draw an isosceles triangle of 100 mm long base and 110 mm long altitude. So the altitude of the triangle is 110 millimeters. Then the base is 100 mm. The altitude is 110 and base is 100 mm. So with these dimensions, so we have to construct a triangle. Inside the triangle, and we need to inscribe a parabola by using tangent method. This is the problem now. Now let us construct a triangle with the given dimensions. The length of this triangle is 100 and the altitude is 110. Then join all these points so we can construct a triangle. So then name this point as A, B and C. Then divide its both sides into the same number of equal divisions. So divide AC and BC into convenient equal number of divisions. Say in this case, I am dividing into 12 equal divisions. So AC into 12 equal divisions and BC into 12 equal divisions. So name all those points. So in this case, is dividing 15 equal divisions, then in this case, in left side and right side, I'm dividing into 15 equal divisions. Uh, 14 and 15 equal divisions. Okay, so then join the 14th line. So 14th line, 14th point here, and 14th point at this location, and the first point here and first point at this location, second point here and second point at this location, third to third, fourth to fourth, and finally 14 to 14. So like this, we connect all these points in this manner. So 6 to 6, 7 to 7. So 7 to 7 is a, I mean, a horizontal line. It looks some inclined line, but it is a horizontal line. 8 to 8, then 9, 10, 11, 12, 13, and 14. So similarly, 1 to 1. So now draw a curve which is tangent to 1, 1, 2, 2, 3, 3, 4, 4, and up to this point to get a smooth curve. That curve is known as parabola. Parabola in tangent method. We are calling this as a tangent method because we are not obtaining any points to draw the curve. Here we are drawing the parabola or a curve as a tangent to all the lines that we are having here. So draw a smooth curve by joining all these 1, 1, 2, 2, 3, 3, 4, 4 up to 14, 14. So we will get a smooth curve like this, and this curve is also a parabola. I repeat this tangent method once again. I repeat this tangent method. We have a problem. So that problem is to construct a parabola in tangent method. So draw an isosceles triangle. This is what the given problem. Draw an isosceles triangle of 100 mm long and 110 mm altitude, height. Inscribe a parabola in it by method of tangents. But we have to use the method of tangents to draw the parabola in this case. So construct a triangle first. Construct a triangle with the given dimensions. In this case, the length of this triangle is 100 and altitude is 110. So with the given dimensions, construct a triangle and name the points as A, B, and C here. Then divide the sides of this triangle. Divide both the sides of this triangle, namely AC and BC, into convenient equal number of divisions. Say in this case, the divisions are 15. Need not be 15. We can take more than 15 or we can take less than 15. If we take sufficient number of points, we will get a very good curve. If we take less number of points, it is a bit difficult to draw the smooth curve. If we take more number of divisions, so we will get more number of points, or more number of locations from which we can draw the parabola or a smooth curve. So after, divide both the sides of the triangle into equal number of divisions. Say in this case, I'm dividing into 15 equal divisions. Now you say AC, divide AC into 15 equal divisions like this, and name these points as 1, 2, 3 up to 50. And the other side also, name all those points from 1 to 15 like this. So the order is also very, very important. So 1 to 15, and here from 1 to 15. So after dividing the sides of the triangle into equal divisions, convenient equal divisions, then join the first point at the top and first point at the bottom. Second, then third point and third point, fourth point and fourth point like this. 1 and 1, 2, 2. Join third point on the left side, third point on the right side. Join fourth point on the left slant line and up to the right slant line, 5, 5. 6, 6, 7, 7, 8, 8, 9, 9, 10, 11, 12, 13, 14. Then draw a smooth curve touching all the lines will give us a smooth curve. That curve is nothing but a parabola. This parabola we are calling as the method is tangent method, because we are getting a smooth curve by drawing in such a way that touching all the lines is called parabola, like this. Now let us see constructing a parabola, directrix and focus method. This is a general method to construct parabola using directrix and focus, as we did in the case of ellipse. So fixed line, let us recall all the concepts in this problem. So I read out the problem to use directrix focus method to draw parabola. Then point F is 50 mm from the vertical straight line. That means it is a directrix. Then draw a locus of point P moving in a plane such that it remains constant. It always constant or always remains equidistant from point F and line AB. A point is moving in a plane such that the ratio of the distances from fixed point to the fixed line is equal to 1. That means a point is moving in a plane such a way that the distances of this point from a fixed point, it's a focal point F to the fixed line is the same. So that is the problem here. So that means the equidistance means the eccentricity is 1. The distance, the ratio of distance of the point from the fixed point to the fixed line is equal to 1. Means the point is moving in the same plane. The point is moving in a plane in such a way that the ratio of distances of this point from the fixed point to the fixed line is equal. So let me go inside. So locate a center first and draw a vertical line. Locate a center or draw a vertical line, and from that point, from the center point, draw a horizontal line. And on that line, locate a point P, which is at a distance of 50 mm from center, like this. So this point is at a distance of 50 mm. We can call that point as focus. Okay, now divide this into equal number of divisions. Say this F is at a distance of 50 mm. So that means this point we will get at 2.5. So midpoint exactly, because the eccentricity is 1 and this point is V, or a vertex here. Now uh, this is called vertex. Now you draw some vertical lines to the right side of the V point. Draw the vertical lines from at a convenient distance, say in this case 5 millimeters, in this case 5, 5, 5, 5, or 10, 10 also we can take. But so the distance from V to F is in this case is 2.5. So 5 mm distance, at a 5 mm distance. So draw the vertical lines from all these points like this. Draw the vertical lines like this. Then take O1 as radius, then take O1 as radius and F as center. O1 as radius in our compass, O1 as radius with F as center, intersect the vertical line at P1 and P2 like this, at P1 and P2 like this. Then take O2 as radius with F as the center, intersect the second line at these locations like this. Intersect the second line at this location and name those points as different points, and similarly proceed further for the third point, third line and fourth line like this. So take O3 as radius, F as center, then intersect or cut the line, vertical line, cut the third vertical line at two locations, at top and bottom like this. Then take the fourth O4 as radius with F as center. Then mark the points like this. Then join all these points from V to get a smooth curve like this. So this method is called Directrix method, Directrix-focus method. It is also a general purpose method, a general method to draw the parabola. I repeat this problem once again. I read out the problem, then I move further to see. We are going to draw a parabola in Directrix-focus method. It's a general method to draw the parabola. Using focus point, then directrix, a point is going to move in a plane in such a way that the ratio of distances of the point from the fixed line to from the fixed point is equal to 1. That means the point should move in a plane with equal distances from the vertical line and as well as the fixed point and fixed line. So that the path traced by that point is nothing but the parabola. If a point moves in a plane in such a way that the point is moving in a plane in such a way that the ratio of distances of this point from the fixed point to the fixed line is equal. That means the ratio is 1. I read out the problem. Point F is 50 mm from a vertical straight line. It is a directrix. Draw focus of point P. That means our fixed point is at a distance of 50 mm from the vertical line. That means it is a directrix moving in a plane such that it always remains equidistant from point F and line AB. Okay. Now let us see how do we construct that. Then locate the center of line. Okay. Then draw a vertical line. Then name that vertical line as AB. Then draw a perpendicular to AB line like this. And on this line, mark a point at a distance 50 mm from O. Then divide this F into, because it is a 50 mm length line, so 5 equal divisions we have to do, and mark a point at a distance, because here this is a parabola, so vertex we need to locate. This vertex, that means, is a moving point. Now this point is exactly lying on OF line. That means this point is equidistant from AB and as well as F, that is called vertex here. Now this is the first point at the reference point to draw our curve. So now the vertex is exactly 50 mm distance, 25 mm distance from O and 25 mm distance from focus. So 25 mm from the fixed line, directrix, 25 mm from fixed point. Okay, so then fixed point, and this point is equal distance from fixed point and fixed line. So now after locating vertex point, then draw the convenient lines, vertical lines to the right side of the vertex point like this. Say I'm drawing 4 vertical lines at a distance of 5 mm. So draw the 4 vertical lines to the right side of the V or the vertex. In this case, I'm drawing 5 mm vertical lines like this. Then take O1 as radius, with F as center, get the 2 points to intersect the first vertical line. That means O1 with F as center intersect the first line at P1 and P2. That means with F as center, intersect this vertical line to get 2 points. Then O2 as radius, take O2 as radius with F as a center, then get the remaining 2 points on the second line like this. So O2 as radius with F as center, intersect this line at P3 and P4 here, like this, P3 and P4 here. So now O4 as radius with F as center, intersect this fourth line at two locations like this, at two locations like this. So now after getting these points, join all these points to get a smooth curve like this. Okay, so now I repeat this once again, this problem. This method of drawing parabola is Directrix-focus method. In this case, we are using Directrix and focus to draw the parabola. That's why we are calling this method as Directrix-focus method. I read out the problem once again. Point F is 50 mm from a vertical straight line AB, that is our directrix. Draw locus of point P moving in a plane such that it is always remains equidistant from point F and line AB. Point F is 50 mm from vertical straight line. That means focal point is 50 mm from the fixed line. That means it's a directrix is 50 mm. A point is moving in this plane in such a way that it is maintaining the equal distance ratio and it is moving at the equal distance from the fixed point to the fixed line, so that the eccentricity is 1. When the distances are equal, then the eccentricity will become 1. In the case of ellipse, the eccentricity is less than 1. In this case, the eccentricity is equal to 1. Now locate the center line here. Then name all those points as AB here. Then locate the vertex point. Here. So this vertex point is exactly at the mid of the OF. OF is 50 mm. Then V will be 2.5 centimeters or 25 millimeters from O or from F. This V point is lying 15 mm, 25 mm from directrix and 25 mm from focus. Now draw the vertical lines to the right side to O. Say 5 millimeter distance. At 5 millimeter distance, I'm drawing 4 vertical lines like this. Preferably equal distance. Need not be equal distance. These lines need not be equal distance. I mean, the distance between these vertical lines may also vary, but prefer to take the equal distance. Now, OB, AB. So now, O1 as radius. Take O1 as radius with F as a center. Intersect this vertical line at P1 and P2 like this. P1 and P2 like this. And similarly, take O2 as radius with F as center to get P3 and P4 like this. And similarly, with O4 as radius with F as center intersect this fourth vertical line at two locations, 4, 5 and 6 like this, 5 and 6 like this, and similarly proceed further to get a curve. This curve is called the parabola. Now, parabola to a point of known coordinate distance. This is also we need to parabola. Sorry, it is a hyperbola. Hyperbola to a point of known coordinate distances. A point is 40 mm and 30 mm from the horizontal and vertical axis respectively. Draw the hyperbola through that point. This is what our problem. The point is 40 mm and 30 mm from horizontal and vertical axis respectively. Draw hyperbola through it. Now draw a horizontal and vertical line. So where these two lines are intersecting, that we can call as origin point. Locate a point at a distance of 40 mm height and 30 mm distance. But in the problem it is mentioned 40 and 30 mm horizontal and vertical respectively. But in this problem, please make a correction. This length should be 40 and this length should be 30. Please make a correction. Otherwise, take this value as 30 and this value as 40. So the height is 40 here and the horizontal distance is 30 here. But in the problem it is specified 40 mm and 30 mm from horizontal and vertical respectively means the horizontal distance is 40 and vertical distance is 30. But please swap these values. So 30 and 40. Instead of 40 and 30, read these values as 30 and 40. So after marking this point, so mark the point and name that point as P. And this point is at a distance of 30 mm and 40 mm along x and y axis respectively, horizontal and vertical axis respectively. After locating that point and divide this height into equal number of divisions. Say in this case, I'm dividing into 4 equal divisions, 1, 2, 3 and 4. And similarly, divide this horizontal line also into convenient number of equal divisions. Say, so this height I have divided to 4 equal divisions, but this I have divided to 3 equal divisions. So doesn't matter. So 3, the 4 and 3. And extend this point P along horizontal axis and extend point P along vertical axis like this. Extend P in the vertical axis like this. And similarly, draw the lines from the origin which must pass from 1 to 3 points on the vertical line here. And similarly, draw the line up to the horizontal line which is the extension of P, which must pass from 1, 2 and 3. So we will get, and similarly from the origin O and draw the lines which must pass from 1 and 2 from here. So up to the vertical line, So we are obtained some points here. Okay. So then we have to locate the points. Like this. From the horizontal line, so drop a vertical line here and draw a horizontal line from point 1 like this. So name these points as 1, 2, 3 and name this point as 1, 2. Okay. So because this line, so this point we are obtained by passing this line from point 1. So this point we are obtained by passing this line, by drawing this line from point 2. So in that way, we are giving the same names 1, 2, 3, 1, 2, 3 and 1, 2. And after getting these points, so drop a vertical line here, draw a horizontal line here, like this. Draw the vertical lines and similarly draw the horizontal lines to get an intersecting point. And similarly from 2 also, draw a horizontal line, and from the 3, draw a horizontal line to get a point 3. And similarly here also. So name those points, and similarly drop a vertical line from point 1 and from 2 also, and draw a horizontal line from point 1 here, and draw a horizontal line from 2 here. So then locate the points like this, then connect these points to get a smooth curve is called hyperbola. This is known as the method of drawing hyperbola in coordinate system. I repeat this problem once again. Okay. So let me check. Okay. So let me repeat this problem once again. Point P is 40 mm and 30 mm from horizontal and vertical axis respectively. Draw the hyperbola through it. Okay. Then point P is 40 mm and 30 mm from horizontal and vertical axis respectively. Draw the hyperbola through it. Now draw the horizontal and vertical axis, which we get some origin, and from this origin locate point P at a distance of 30 mm on the horizontal axis, 40 mm on the vertical axis like this. So this is our point. So this point is at a distance of 30 mm from the origin and along x-axis, 40 mm from the origin along y-axis like this. So this point is P. Now extend point P or divide this vertical line at point P into convenient equal number of divisions like this. Convenient equal number of divisions like this. And similarly, divide this horizontal line of point P into convenient equal number of divisions. Say, I am dividing this into 3 equal divisions like this. 1, 2, 3. And I have divided the height of this point 40 into 4 equal divisions. I have divided this 30 into 3 equal divisions. So then extend point P horizontally, then extend point P vertically also. Then draw the lines up to the extended line, up to the line extended from point P, and those lines must pass from 1 to 3 to get the points on the extended line like this. From the point O, draw a line that must pass from point 1, which will intersect the extended line at P like this. Then similarly from 2, similarly from 3, and similarly from the horizontal line and like this. So we have not obtained actual points here to draw hyperbola. So now locate the points on the extended line from P as 1, 2, and 3. And similarly, so indicate this point as 1 and indicate this point as 2. And after that, drop the vertical lines from the extended horizontal line like this. And similarly, draw the horizontal lines like this. So 1, 2, and 3 points were obtained. And similarly, on the horizontal line also. So draw the vertical line. Okay, locate the points, draw the vertical line, draw the vertical lines, then draw the horizontal lines like this to get the points. If we join all these points, so we will get a smooth curve. So that curve is called hyperbola. So like this, join all those points. So just like this, to get a smooth curve. So this is called the hyperbola. So now let us draw an hyperbola, which is a PV diagram. He is given some values. Pressure PV equal to constant curve we have to draw. It is a hyperbola. In this case, he is given some values. A sample of gas is expanded in a cylinder from 10 unit pressure to 1 unit pressure. A gas is expanding from 10 unit pressure to 1 unit pressure. Expansion follows PV is equal to constant law. If initial volume being 1 unit, and draw the curve of expansion. This is what the problem. From the table, giving few more values of P and PV equal to constant like this. So take all these values. 10 into 1 is equal to 10. If 10 becomes 5, 1 will become half. If this will become 4, this will become 2.5, 2.54, 25, 110, like this. So let me draw this also here. So draw a vertical line and horizontal line. Locate the origin. Then on the vertical axis, I am indicating I am taking pressure. On the horizontal axis, I am taking volume. Because it is a PV diagram, normally in thermodynamics, the vertical axis will become the pressure and the horizontal axis become the volume. And similarly, so take the units, 1 unit like this, and on the vertical axis also take the units 1 axis and plot the values. P10, if P is 10, and locate the points like this. If P value is 10 and V value is 1, if P value is 10 and V value is 1, if P value is 5, if P value is 5, V value is 2, like this. So just like this, okay. Volume and pressure, 10, 1, yes. Next 5, 2, then 4, 2.5. This is our 4 and this is our 2.5. 2.5, 4, okay. Then 2.55, like this. And similarly, 2, 5. From then you join all those points. So to get a smooth curve, so this curve is called hyperbola. So this curve is called hyperbola, so a smooth curve. Now let us draw the hyperbola in Directrix-focus method. So now let us see, point F is 50 mm from